The other type of point-to-point technology that we may choose, and most companies will standardize on, is what is known as PPP, the point-to-point protocol. The point-to-point protocol is designed to operate across any DCE or DTE interface connection. The data terminal equipment, which is normally the router and any device that exists in the cloud, which is known as data circuit terminating equipment or data communications equipment. Those are normally the equipment interfaces that are identified by the providers. One of the nicest things about PPP is that it does operate across any circuit, with the only restriction that it has to be a duplex circuit. It operates in both synchronous and asynchronous mode. So it can be used equally well on dial-up connections or ISDN as it can on a T1 line. The best thing about it, though, is that it does not have any transmission rate limits that would be incurred on other types of line protocols such as HDLC. Point-to-point protocol is typically what most companies will standardize on for their T1s, for their ISDN connectivity, for the dial-in access, and every other connection that they have that goes router to router in a point-to-point fashion. The point-to-point protocol is excellent, and at the same time, it does provide multiple Layer 3 protocol support. So you can route IP, IPX, and AppleTalk simultaneously over the same line. One of the other benefits, especially in today's day and age, is the use of security. The point-to-point protocol has many added benefits, and one of them is authentication. You can choose to use one of two flavors of authentication. Either the Password Authentication Protocol, or PAP, which is a clear text authentication, or even better, Challenge Handshake Authentication Protocol, or CHAP, which is an encrypted authentication using MD5 algorithm. When you look at the PPP architecture, it is actually quite simple. It's an RFC-compliant element, and it must be implemented as such. The point-to-point protocol actually provides all of the Layer 2 characteristics that are required for point-to-point data communications, whether synchronous or asynchronous, and it is actually split into three different components inside of Layer 2. The lower component is the standard HDLC frame, not the Cisco proprietary frame, but the standard HDLC frame, because we have to implement the point-to-point protocol in its RFC native format. It means the PPP can talk to any device. We don't have any problems dealing with multi-vendor environments. One of the reasons why most companies love to standardize on PPP for their serial connections is that it supports multiple vendors' equipment. Above that is an element, which is known as the Link Control Protocol, or LCP. Its job is to provide the initial connection setup between the two remote ends. It will actually provide link quality and link integrity testing, verify that the link can be maintained successfully, and also do the authentication for the line. Very, very nice to have a sub-protocol such as this that can actually guarantee that the line is consistent enough to be able to maintain the PPP connection. Once it is identified that the connection is intact and does have a high level of integrity, it will turn control over to a family of what are known as Network Control Protocols, or NCPs. NCPs implement the specific Layer 3 protocol that you happen to be running, and there is a separate NCP for every protocol that you might route. If you currently are only routing the IP protocol at Layer 3, you will only have one NCP loaded, which is the NCP that is specific to the IP protocol.